Hi boys and girls, welcome to another video lesson. This is for section 1.6 on solving linear inequalities. And today our objectives are to solve simple and compound inequalities and to interpret the meaning of a solution in terms of the graph it represents. So in this lesson, certainly we're going to focus on the compound inequalities. You spend a good amount of time in Algebra 1 solving these simple ones. So I'm not really starting there. I'm starting with the compound ones. And we're also going to look at the meaning of these things. Okay. So, and by the way, you should have also done compound inequalities in Algebra 1, but this is really what your focus is on for this class. Okay. So I want to make the distinction between the word and versus the word or, particularly when we're looking at compound inequalities. So look at these two statements. The first one says x is greater than -3 and less than 4. Can you think of a number that's greater than -3 and less than 4 at the same time? Well, yes. And the way I'm going to think about this is on a number line. If I have -3 here and I have 4 here, well, let's see, greater than -3 is going to start here and go to the right, and 4 is going to end right there. All those numbers between 3 and 4 are greater than -3, between -3 and +4. These are all greater than -3, and at the same time, they're less than 4. So our compound inequalities that have and in it, they're going to look like what this graph looks like right here. They're going to be this little segment that may or may not have filled in circles. Okay, let's look at the second scenario. X is less than -3 or is greater than 4. I'm going to ask the same question. Can you think of a number that's less than -3 and greater than 4? I certainly can't. So this really has to be an or situation. So the idea that it's less than the first value and greater than the second, this has got to be an or situation. And if you look at this, x is less than -3. That's this open circle going to the left. And greater than 4, or greater than 4, I should say, is an open circle going to the right. So this is what our or situation looks like. We're going to have these rays going in opposite directions. And again, these may or may not be filled in circles. And you should know that they're filled in when it's or equal to, right? Like that. Those are filled in circles. Open circles, these are closed or filled in. Open, less than or greater than. Again, that should be known from your Algebra 1. Okay, so let's look at an and inequality. Again, this is a compound inequality, and the and inequalities will look like this when you start with them. Sometimes we'll have word problems, and you need to write it like this. So let's first look at why this is an and inequality. So I'm going to take my hand here, and I'm going to read this as, okay, 2t plus 7 is greater than or equal to 1, and at the same time, it's less than or equal to 15. So I have both of those happening all in one equation here, one inequality here. In some ways, the and inequalities are kind of nicer to solve because I can really do this all at once. Here's the way I look at this. I imagine little barriers here at my inequalities. And I'm really just focusing in on the center, that 2t plus 7. And I'm going to unwrap that. The left and the right side, where the 1 and the 15 are, that's just going to be the consequence of what happens when I unwrap the 2t plus 7. So I'm really looking on the inside, and that tells me to subtract 7. Well, as a consequence, I need to then do that on both sides of the inequalities. And now I get -6 is less than or equal to 2t, which is less than or equal to 8. Okay, I'm going to keep unwrapping. I'm going to divide by this 2 on the inside here, which means I need to divide on both the left and right sides as well. And I get -3 is less than or equal to 1t is less than or equal to 4. And again, I can keep all these things nice and separate. And now I've got t all by itself, and there's my solution to my compound inequality. And what I'm going to do now is I'm going to graph this solution as well. And I want you to do this as well. So I'm going to put -3 on here. I'm going to put 4 on here. And again, my solution t is greater than or equal to 3. I'm going to put my hand over the right side here. So I'm going to take my hand and say, okay, I'm going to cover this up and say, all right, so -3 is less than or equal to t, or better yet, t is greater than or equal to -3, and at the same time, t is less than or equal to 4. So this is an and situation. You can certainly read this directly across left to right, but I like to read it in 2. Again, t is greater than or equal to -3, and t is less than or equal to 4. So for both of those things to happen, I need to have the bar go from one to another. And again, these are closed circles now because it's a less than or equal to in this case. And again, you can also test this out. Does the number that's in between here, like 0, does this answer the question? The number that's greater than -3 and less than 4 at the same time, 0 certainly works. And I know 0 is in here somewhere, right? Okay. Let's look at another compound inequality. This time this is going to be an OR inequality. What's nice about the OR inequalities is they stay separate all the time. And we often, 99% of the time or more, we see the word OR. So we need to know when we see the word OR, our solution is going to look something like this. Circles going each way, right? In fact, I'm going to leave it just like that. And when I get my numbers, my solutions, I'm just going to put them right out to this graph, and everything's going to work out really nice. Because I know this is the shape. I know that this is what this is supposed to look like up here with these 2 rays pointing out to either side here. So really, I'm going to solve these separately, and then I'm going to get my 2 solutions. Or I'm going to combine these into one solution, rather. Okay, so I'm going to subtract 7. I get 2a is less than -6. I'm going to divide by 2. And I get a is less than -3. So here's my a less than -3 going on right over here. Right? This little ray right here is going to represent that part of the solution. All right, now I'm going to work the right side. I'm going to add the 7. And I get -3a is greater than -12. And now I'm going to divide by this -3, so I can get a by itself. And I'm dividing by a negative with an inequality. So what do we need to do here? Well, I need to flip this inequality sign. Notice how that got flipped, right? It's not pointing the other way. So now I end up with a is less than 4. Okay, and I paused there because I made a mistake in the setup here. This was supposed to be a less than symbol here. So I'm actually going to go by and fix all this stuff. So my apologies for that. Those are less thans and less thans. And now when I've done this division, I have to flip the sign, and I get a is greater than 4, which is what I intended this to be. So my apologies for that, and sorry that you have to go back and fix that. Anyway, so I do get the solution I'm looking for. I get these 2 rays, one pointing left, one pointing right. And again, this is the OR situation that's pointing away from some center point, if you will. Okay, let's now look at this in some kind of a application context here. So water is a liquid between the temperatures of 0 degrees Celsius and 100 degrees Celsius. So what I'm going to do at this point is I'm going to write this as a compound inequality, and then I'm going to convert this inequality to degrees Fahrenheit. And I have over here on the right side our conversion to go from Fahrenheit to Celsius. This is not something you need to memorize, so that's why I'm sharing it with you today. Okay, so the first part of this, I know my temperature in Celsius is between 0 and 100. So this is actually pretty easy write-up here. I know C is going to be, my degrees in Celsius is between 0 and 100. So I'm going to write it like this. C is going to be greater than or equal to 0, and at the same time, less than or equal to 100. And I'm done with that first part. I've expressed this as a compound inequality. And again, this is an and situation, right? It's got to be greater than 0 and less than 100 degrees at the same time. Okay, so now for the conversion here, essentially what I'm going to do is I'm going to put this expression for C, 5/9 of f minus 32. I'm going to substitute that in, and then I'm going to unwrap here. So I have 0 is less than or equal to, and in place of C, I'm going to put 5/9 f minus 32. And now it's a matter of just unwrapping here. And by the way, if you know your conversions from Fahrenheit to Celsius, or if you know where water freezes and boils, you actually know what the solution is. And let's just hope that we actually get it, right? Okay. So I'm trying to fix this. Okay. So I'm going to put my little bars here. Again, this is just for your own, so that you see what I'm thinking here. You definitely don't need to put these vertical bars down here. Okay. So first thing I need to do is I need to unwrap this multiplying by 5/9, and I'm going to do that by multiplying by 9/5. And again, I need to do that on all three positions, all three sides, if you will. So on the left side, I get 9/5 times 0 is going to be 0, is less than or equal to, well, these cancel, right? 9 and 9, 5 and 5. Okay, I get f minus 32. I'm actually going to get rid of the bars. I think they're causing more trouble than they're worth. Is less than or equal to, and I need to do 100 times 9/5, and that's going to be 180. And the last thing I need to do, again, my focus is on the center here, right? I'm looking at what's going on inside here. Well, I need to unwrap that subtracting of 32, so I'm going to add 32. And again, do that to all three parts here. And I get 32 degrees is less than or equal to F is less than or equal to 212. And if you know your freezing and boiling temperatures for water, then this actually hopefully should make some sense here. That water is a liquid between 32 degrees and 212 degrees in Fahrenheit. Okay, so let's take that same idea. And now I'm going to ask you folks to write a compound inequality for when water is not a liquid. So I know water is a liquid between 32 and 212 degrees. Where is it not a liquid? And I want you to write this using an or statement, and then I'm going to have you folks convert it over to Fahrenheit. So if you haven't already, pause it here, and I'm going to write the solutions. Okay, so where's water not a liquid? Well, it's when your degrees in Celsius is less than 0, or if you had less than or equal to, that's fine, or when your degrees in Celsius is greater than 100. And again, those can be or equal to, that's just fine. And then when you convert this, you should get that Fahrenheit is going to be, it's when your Fahrenheit degrees is less than 32, or your Fahrenheit degrees is greater than 212. And again, I'm looking at, okay, did you get the numbers right? That's certainly good. But also you should get the fact that this is two parts, and you need this or statement in between. Okay, so to sum this up, our objectives were to solve simple and compound inequalities. We did that, and we also interpreted the meaning of these solutions in terms of the graphs with the number lines that we did, with the rays pointing into each other or pointing away. So again, I hope you found this helpful, and I look forward to seeing you guys in class. Take care.